What if the cosmic rays that travel halfway across the galaxy and the particles in accelerators aren't being pulled but are instead following a carefully laid out map created by the field itself? In the energy filament theory, particles aren't being dragged through space. Instead, they are simply following the guidance of a field that maps out their optimal path, making sure they stay on track as they move. Imagine the entire energy sea as a vast, living map, where the field's tension and texture from the terrain. The tension field tells you where the slopes are steep or shallow, and the texture field shows which paths are smoother and more stable. As we discussed in Season 2, each particle also has its own local field texture. Like the treads on different types of tires, some work better on dirt roads, others on highways. So, when we talk about particles moving through the field, it's like a car speeding forward while its tires continuously read the roadmap, picking the most stable and efficient route to follow without losing its structure. A perfect example of this is cosmic rays. These particles travel from distant parts of the universe, passing through magnetic fields of stars, galaxies, and large-scale structures of space-time. As they go, the fields rewrite their paths, guiding them along the most efficient trajectories, depending on which way the magnetic field lines flow or how steep the space-time slope is. These cosmic rays get slightly deflected, but they eventually found their way to Earth after navigating multiple detours, all while following the optimal path mapped out by the field. In accelerators, magnets create a similar effect, but this time it's artificial navigation. Engineers use segments of magnetic fields to create a finely tuned map, bending the energy sea's texture into a series of sharp curves. Particles like protons and electrons move along this map, automatically selecting their paths as they race towards near-light speeds. The particle beam we see is not just a random trail, but the bright lines showing the best route they had chosen according to the field's design. Black hole jets represent the most extreme form of this field navigation. The intense gravity of a black hole, combined with its magnetic texture and rotational fields, forces nearby plasma and high-energy particles into narrow channels. Even though these particles might want to scatter in different directions, the field's design pushes them into two thin, focused jets. It's like the field has drawn a set of extreme road markings that force the particles into specific paths on a cosmic scale, rather than thinking of the field as exerting a mysterious force on the particles. It's more accurate to say that the field has already created a map of preferred routes, balancing efficiency with the safety of the particle's structure. The particles, in turn, follow these routes, picking the path that best suits their local field texture. The orbits, deflections, and jets we observe are just the visible results of their journey along this roadmap. Next season, we'll officially redefine force as the outcome of this search for the optimal route. For now, remember this phrase: the field designs the route, and the particles find the way. Tap follow, share it on New Physics, Clear Universe.